This video is on using moles to balance equations. Now, in previous videos, we have used a balance equation to work out the mass. But we can also, and you can also be asked to go the other way and use the masses to work out the balanced equation. So I'm going to show you how to do that now. So the best way to do it, of course, is through worked examples. So here's the first worked example. Sodium nitrate, NaNO3, decomposes to give sodium nitrite, NaNO2, and oxygen gas. When 8.5 grams of sodium nitrate is used, 6.9 grams of sodium nitrate and 1.6 grams of oxygen is produced. Construct and balance an equation for this reaction. So the first thing we have to do is construct the equation using what we've been given. Okay, so we just take it through in order. So we know that sodium nitrate, which is Na, so let's write this underneath our question, NaNO3, decomposes, okay, so decomposes to give sodium nitrite, which is NaNO2, plus oxygen, which we know is O2. So that is going to be the equation. However, we know that's not balanced. Now, you could, of course, just balance it like I've taught you before, but it's not asked you to do that. It's asked you to use the masses to balance the equation, so you have to do that. So you have to follow these steps. Okay, so the first thing we need to do is write the masses of each of them underneath. So we've got here sodium nitrate. Now the mass in the question, when we look, it's been given as 8.5. Okay, so we're going to write that underneath, 8.5. Then we've got sodium nitrite, and the mass being given to that one is 6.9, so we're going to put that underneath like that. And then finally is oxygen, it's given us 1.6 grams, so we're going to do that. Okay, so the first thing you do is write underneath the equation the masses for each of them. Then what you've got to do is you've got to work out the MR of each of them as well. Okay, so remember, if you don't know how to work out the MR, go back and watch that video. But let's work out the MR of these. So we've got sodium here, Na, and if we look on our periodic table, the mass of Na is 23, so we're going to put 23. Then we've got N, nitrogen, and the mass of our nitrogen, when we look on the periodic table, remember it's the larger number, is 14. And O3, we've got O3 here. Now oxygen, the mass of oxygen is 16, but there's 3 of them, so times it by 3, so it's 48. Okay, now if we add them all up, okay, to work out the total MR, we get 85. So if we do 23, add 14, add 48, we get 85. Okay, so what you're going to do with that is do a little line underneath your grams and then write 85 there. Now we've got to work out the MR of the next one. So again, Na is 23, N again is 14, and this time it's O2. Okay, so O is 16, remember, so O2 is 32. And if we put these in the calculator, 23, add 14, add 32, you get 69. Okay, so we're going to put that here, divide that by 69. And finally, oxygen, O2. Okay, O, obviously oxygen is 16, O2 is 32. And that's all it is for that one, so we're going to put that underneath there. Okay, so now we can use our moles equals mass over MR equation to work out how many moles is in each of these by doing exactly that. The mass, which is, remember, the top number, divided by the MR, which is the bottom. So we've already put it in our work how we're going to lay it out and what we're going to do. So 8.5 divided by 85, if we put that in a calculator, we get 0.1. You've got 6.9 divided by 69. If you put that in a calculator, again, you're going to get 0.1. And then if you do 1.6 divided by 32, you're going to get 0.05. Now what that tells you is that 0.1 moles of this, of sodium nitrate, reacts to give 0.1 moles of this, sodium nitrite, plus 0.05 moles of oxygen. So that's what that tells you. But of course, when we're doing with balancing equations, we can only deal in whole numbers. So we can't put 0.1 here in front of that. We have to convert it into a whole number first. Okay, now the easiest way to do that is to divide them all by the smallest number. So here we've got 0.05 is the smallest number, so we're going to divide them all by that. Now 0.05 divided by 0.05 is obviously just 1. 0.1 divided by 0.05, if you put that into a calculator, you get 2. And again, 0.1 divided by 0.05, again in a calculator, is 2. So that now tells us that 2 moles of sodium nitrate reacts to give us 2 moles of sodium nitrite and 1 mole of O2. So we can now put that into our equation. So 2 moles here, so we're going to put that there. 2 moles here, so we're going to put that there. And only 1 mole of here, and we know if it's a 1, we don't put it. And that now is a balanced equation. Okay, so if you were to add up all of that, that would be a balanced equation, and that is your answer to this question. Okay, so let's do another question together before I give you some to do on your own. This time we've got copper reacts with oxygen to form copper oxide. So again, it gives us our masses, so we have to work out a balanced equation. So step 1, let's first construct our equation. So copper, which is of course Cu, reacts with oxygen, which as we just said is O2, to form copper oxide, which is given us there at CuO. And again, this would be a really easy equation to just balance, but if we've been given the mass, then we have to use that to get the marks. Okay, so Cu plus O2 gives us copper oxide. Now the first thing, remember, we do, so step 1, after we've written the equation, is we write the masses of each of them underneath. So copper oxide, so it's 6.3 grams of copper, first of all. So we're going to write that underneath copper, 6.35. Reacts with 1.6 grams of oxygen, 1.6 there. Now it doesn't tell us how much copper oxide is formed. However, to work it out, we can use, of course, the conservation of mass theory. The mass on this side is the same as this side. Okay, so to work out the mass then of copper oxide, we can just do 6.35, add 1.6, okay, is 7.95. Now because it's the only product this side, all that mass must go to that product, and therefore the mass of copper oxide produced is 7.95. Okay, so remember, just to do that, we just added the 6.35, add 1.6 to give us that. Okay, now we've got that, we can find out the MRs of each of our each of our compounds. So here we've got copper, so underneath here we're going to write copper, and if we look on our periodic table, then the mass of copper is 63.5. Now it's only copper, we don't have to work out anything else, so the total mass is going to be 63.5. And O2, remember 1O is 16, O2 is 32. So again, because it's just O2, we can write that underneath our mass. And copper oxide, we've got Cu, which is 63.5, so copper 63.5, and then O, just one oxygen, is 16. And to work out the total MR, of course, we just add them together. So 63.5 add 16, and we get 79.5, and we're going to write that underneath here. And of course, now what we do, you remember from the last one, now we just divide them. We do to work out the moles, we do mass over MR, which is of course the top number divided by the bottom here. So 6.35 divided by 63.5, if we put that into a calculator, we get 0.1. 1.6 divided by 32, we get 0.05. And 7.95 divided by 79.5, we get 0.1. Now remember, this means that 0.1 moles of copper plus 0.05 moles of oxygen forms 0.1 mole of copper oxide. But we can't put that into our equations. They have to be whole numbers. So to get them into whole numbers, to work out the ratio, we again divide them by the smallest number. The smallest number here is 0.05. That's smaller than 0.1. So we'll do 0.05 divided by 0.05, which again just gives us 1. 0.1 divided by 0.05, if we put that into a calculator, we get 2. And 0.1 divided by 0.05, as again, is 2. So that means that 2 moles of copper, and we put 2 there, reacts with 1 mole of oxygen. Now, because it's 1, we don't put a 1 in front, to form 2 moles 2 moles of copper oxide. So we're going to put that there. And again, that is our balanced equation there. Okay, so that's how we balance the equation. That is now done. We've got all the marks for that. Okay, now this topic can be quite difficult, so it'll be a really good idea now if you have a go yourself at these summary questions to really make sure you understand it. So pause the video now to have a go, and then we'll go through it together. Okay, so potassium nitrate decomposes on heating to give potassium nitrite and oxygen, and then it gives us our masses, and it wants us to construct a balanced equation. So the first thing we need to do, as you remember we've done in the previous 2 examples, is we're going to need to construct our equation. So here we've got potassium nitrate, which is KNO3, decomposes, it breaks down to form potassium nitrite, which is KNO2, plus oxygen, which is O2. So that is going to be our equation. The next step, what we need to do is we need to write down the masses given underneath. So our potassium nitrate, KNO3, we've got 4.04 grams, so we'll write that underneath here. And then it gives us our potassium nitrite, which is 3.40 grams. And then, of course, it doesn't give us oxygen, but we know that this side is going to equal to this side. Okay, so here we've got 4.04, and here we've only got 3.4. So if we do 4.04, take away 3.4, then that gives us 0.64 left. So that must be the mass of oxygen formed. So that will be 0.64. So to get that, we just did 4.04, take away 3.40. Now, once we've done that, of course, remember we need to work out the MR, okay, of both of them. So KNO3, you've got K, you've got potassium, which if you look on the periodic table is 39. You've got nitrogen, you've got N, again looking on the periodic table, that's 14. And you've got O3. Okay, now O is 16, times that by 3, you get 48. If you pop them all in a calculator, 39 add 14 add 48, you get 101. And we're going to write that underneath our grams to make sure we know what we're doing. Then the next one, KNO2. So K, potassium, again, is 39. N, nitrogen, is 14. And our oxygen, this time it's O2, so 16 times 2 is 32. Then we add these together, so 39, add 14, add 32, should have given you 85. And finally, O2 is O2. O is 16, times that by 2, you get 32. So we're going to write that underneath there. We then need to work out our moles by doing moles equals mass over MR. So the mass is 4.04 here, divided by 101. So you pop that in a calculator, you get 0.04. Now we're going to do 3.40 divided by 85. I pop that in a calculator, again you get 0.04. And finally, you want to do 0.64 divided by 32 to work out oxygen, you get 0.02. So that means that 0.04 moles of potassium nitrate forms 0.04 moles of potassium nitrite plus 0.02 moles of oxygen. But again, we can't put these into our equation, so we have to make them whole numbers. So to do that, we're going to divide it by the smallest number. Now the smallest number out of these three is 0.02. So let's divide them all by that. 0.02 divided by 0.02 is 1. 0.04 divided by 0.02 actually gives you 2. And 0.04 divided by 0.02 again is going to give you 2. So that now tells us that 2 moles of potassium nitrate, so 2 moles, we're going to put that there, forms 2 moles of potassium nitrate, so we're going to put that there, and 1 mole of oxygen. And again, because it's 1 mole, we don't write that, so we just leave it there. So that should have been the answer you got for your balanced equation for this reaction. Now again, because this is quite a difficult concept to understand, it would be a really good idea if you now have a go at answering this question here to really check your understanding. So pause the video now to have a go. Okay, so iron 3 oxide, which is Fe2O3, reacts with carbon to give iron metal and carbon dioxide. And again, it gives us our masses here, and it wants us to construct a balanced equation. So step 1, let's first construct our equation. So iron 3 oxide, which is Fe2O3. Okay, that's a very poorly written 3, so let's do that again. O3 reacts with carbon, which is C, to form just our iron metal, which is Fe, and carbon dioxide plus CO2. Now we need to write out our masses underneath each of them. So 480 grams of iron oxide, so we're going to write that here, 480, is heated with carbon. It doesn't tell us what that is, so we're going to need to work that out. And it produces 336 grams of iron, so we'll write that underneath iron, and 198 grams of carbon dioxide, so 198 grams there. Now again, we know that the mass of the left hand side needs to equal the mass of the right hand side, so we can work out what this mass is here. We can work out the mass on the right by doing 336, add 198, so 336 add 198, and that gives us 534. So this side equals 534, so this side has to equal 534 as well. We've already got 480, so if we do 534, take away 480, you get 54. So it must have been 54 grams of carbon, so we can write that underneath now. Then what we need to do, of course, is we need to write the MRs. We need to work out the MRs for all of them. So Fe2O3, so Fe2, if we worked out the MR of that, we get 112. And O3, we work out the MR of that, we get 48. Now if we work out the MR of carbon, the MR of carbon is 12. Moving on, the MR of Fe is 56. Okay, so one Fe is just 56. And then carbon, C, gives us 12. And O2 gives us 1 oxygen 16, O2 32. Now we add them together, obviously, to get our MRs. So 112 add 48 is 160, so we're going to write that underneath there. Our carbon is just 12, so we can write that under there. Our iron is just 56, so we're going to write that there. And carbon dioxide is 12 add 32, which gives us 44. So we're going to add that there. Now we need to work out our moles for each of them, so we do mass over MR. So 480 divided by 160 to work out the moles of iron oxide. If we put that in a calculator, 480 divided by 160, we get 3. 54 divided by 12, now 54 divided by 12 is 4.5. 336 divided by 56, pop that into a calculator and you get 6. And finally 198 divided by 44, we put that in a calculator, we get 4.5. Now again, these are just in decimals, so we do need to convert them. And again, we can divide it by the lowest one, and the lowest one here is 3. Okay, so we can do 3 divided by 3, which gives us 1. 4.5 divided by 3, and that gives us 1.5. And again, we can't use that, so that's going to cause a problem. So we'll get to that in a second. 6 divided by 3 gives you 2. And 4.5 again divided by 3 gives you 1.5. Now because we've got nice numbers here, 1.5, but they're not whole numbers, what we can do is we can double them. Now if we double these, it means we also have to double the remaining ones as well. So we're going to double all of them. So 1.5 doubled is 3. 1.5 doubled again is 3. Now 2 doubled is 4. And 1 doubled is 2. So that tells us that 2 moles of iron oxide, so we can put that here, reacts with 3 moles of carbon, so we're going to pop that here, to produce 4 moles of iron, and we're going to put that there, plus 3 moles, because it tells us there, of carbon dioxide. And that is the correct balanced equation for that reaction. So this is a rather long video, so I hope you understood it, but we've just there looked at how to construct a balanced equation from the masses. This is usually worth a good amount of marks in your exam, so it's a really good idea to practice these. And there are plenty more practice questions on the website for you to have a go at. As ever, if there's anything you didn't quite understand, please do contact one of our tutors who will happily help. Why are we the best revision website out there? Well, because we have it all in one place. Revision notes, summary videos, longer, more detailed videos for topics you're struggling on, exam question walkthrough videos where qualified teachers take you through the perfect answers to exam questions, worksheets, quizzes, computer marked exam questions, interactive flashcards, forums, the ability to keep track on where you are using our tick list, and so much more. But that's not all. We run at least 3 live lessons a week, and closer to exam time, this will be more, where you can tune into a qualified teacher teaching lots of different topics each week. The lessons will be interactive, and we go through exam questions and quick quizzes to ensure understanding as you go. We also run drop-in sessions where you can drop in, ask a tutor anything live, get the answer that you need, and leave. These are included in our silver and gold membership. This means that for an extra £10 a month, you can access at least 12 hours of lessons a month. That's under £1 an hour, which is incredibly cheap. Still not convinced? Try us completely free for 7 days and cancel anytime, completely free of charge. We offer this because we're convinced that you'll love us. So try us now.